Okay, so today we want to look at this question here that is on your screen. Okay, and this question here requires that you know what we call as the interval notation of the sets. Okay, so for the interval notation of the sets, you have to know what some certain brackets mean, okay, and how to represent them on the number line, and some of the notation like this one here, when they say A minus B, what do they mean? Okay. All right. So let me start by first giving you a hint on what this interval notation is. Okay. So when we talk about interval notation on sets, we are simply talking about representing what we call as infinite sets. Okay. So what are infinite sets? These are sets that contain elements that cannot be counted. Okay. So we are going to use two types of brackets. There's this curved bracket like that, okay? And we also have these square brackets like that, okay? So these two different brackets have different meanings, okay? So if I write A, comma B inside here, and then let me also write A, comma B inside here, okay? So whatever I have there represents what is called as an infinite set, meaning this set contains elements that you cannot count, okay? There are a lot of elements, you can't count them, they are infinite, okay? All right, so if you have a curved bracket there at the end, okay, if you have a curved bracket like this at the end, it means that this number here at the far end here is not included in this set, okay? Even this number here at the end is not also included in this set, okay? And then if you have a square bracket like that, it means this endpoint is included, even that one is included, okay? So this is what we call as an open interval, okay? Open interval. And then this one is what we call as a closed interval. And then from this, we can have a mixture of these intervals, okay? So we can have this, and then comma B, and then there we have a square bracket like that, okay? So this one here is semi-open or semi-closed interval, okay? There's a bracket that is showing that this A is not included in this set, but on the other hand, we have a B that is included in that set, okay? And then it can also be the other way like this. So we have A and then comma like that, okay? So meaning the B is not included in this set, but this A here is included, okay? So you can represent these intervals on what we call as the number line, okay? So on the number line, if you have a curved bracket like this, okay, or a curved bracket like that, you represent this on the number line by an open circle like that, okay? An open circle, meaning that the number under this open circle is not included in that what interval. Remember I said if you have something like this, if you have A, comma B here, it means this A is not included and the B is not included, right? So if I were to have a number line here, okay, and then here I have A, and then somewhere there I have B. On this A, I'm going to draw an open circle. Even on the B, I'm going to draw an open circle like that, okay? And then I'm going to draw a line in between. So every member that's between A and B, they're included in that set, apart from the A and the B, okay? So all the members that you can find between here, they will be part of this set. And then if you have a closed bracket, okay, like this one, it means that if this is my number line here, okay, and then I have my A there, and then I have my B, it means this A is included here because I have a square bracket, okay? So I'm going to shade the circle here. I'm going to shade it like that, okay, meaning that it's closed. And then I'm going to draw a line, and then even there, I'm going to do what? To shade it like that, okay? So this means that starting from the A itself all the way up to B, all these elements are part of that set that we've been given there, okay? So that's what the interval notation is basically about. So know the types of brackets and know what they mean, okay? And then there is a confusion among students, okay? So whenever you have infinity or you have positive infinity or minus infinity, always use the curved bracket, okay? Never use the square bracket on infinity. So infinity, if I have minus infinity like that, and then I'm going to positive infinity like that, okay? You always use the curved brackets like this, okay? When whichever side has infinity, whether positive infinity or minus infinity, always use the what? The curved brackets like that, okay? Something like this does not exist, where we have minus infinity there and then positive infinity like this, okay? This thing here does not exist, so don't ever do this, okay? It's wrong. Always when you have an infinity, always put a curved bracket like that. Okay, so I've explained the basics of what this set interval notation is all about, okay? And then we are going to use this same notation that I've taught to answer the questions that I showed you earlier, okay? So if you have any question as we'll be answering these questions, feel free to ask, okay? So now let's look at the questions. Okay, maybe before we do that, let me talk about one more notation. So if I have a minus b, okay, this here is the same as, okay, it's the same as a intersection b complement, okay? So this minus b here simply means intersection b complement, okay? So we might have to use it somewhere as we are answering those questions. All right, so now let's look at some of these example questions that we have. Okay, right, so here they're saying, let the universal set be a set of real numbers, okay? So a set of real numbers is a set that starts from minus infinity all the way up to positive infinity, okay? That's the set of real numbers. Okay, and then they're saying let A be given by this set, okay? From 3 to 8, where 3 is included in the set, but 8 is not. And then B from 2 to 7, where the 2 and the 7 are both included in the set. And then C, we have 1 to 5, okay, where 1 and 5 are both not included in the set. And then we have a fourth set here, which is D, okay? And then this D starts from 6 all the way up to positive infinity, okay? But the 6 is not included, and as usual, the infinity will never be included in any set, okay? So now, the question is, find the value of A union what? Of A union C. Okay, so how can we find that set, the A union C? Okay, we simply just have to plot the set A on the number line, okay, and then also plot the set C on the number line, okay, and then combine them together. Remember, when we are unionizing, we are getting all the members from one set and combining them with all the other members from the other set. Okay, so this is what we have. If we put it on our board here, we have A, okay, which is given by 3 and then comma 8. Okay, and then C, we were given that it was 6 all the way to what? To positive infinity. Okay, so this is what we have here. So how can we find the union of A union C? Okay, so it's simple, guys. So just draw a number line here.
Just a bit.
Hello?
The set C you've gotten, isn't that set D?
I wouldn't say D. Oh, yeah.
Yes, trying to check.
Let me check. Oh, C is 1 to 5, eh? Okay. Yeah. Even here, I wrote a wrong bracket. Okay, let me get the C. So C is 1 to 5. Okay, so C is equals to 1, comma 5, like that. Okay, so that is our C there, and then this is our A there. Okay, so what are we going to do here? Okay, we can plot our 0 to be there. Okay, and then this set, of course, goes all the way up to minus infinity, because they said the universal set is a set of all real numbers, and this one goes all the way up to positive infinity. Okay, and then let's plot these numbers in order that we can see in these two sets. So I have 1 as the smallest, and then I have 3 somewhere, 5, and then 8. Okay, so let's plot set A using a different color. So set A is starting from 3 all the way up to 8. Okay, so the 3 here is included, so we are going to shade this guy here. And then we are moving all the way to the 8, but the 8 is not included, so we'll put an open circle like that. So this red line here and these 2 circles, they are representing set A. Okay, then now let's plot set B, set C in blue. Okay, so set C is starting from this one here. Okay, so 1 is not included, and then all the way up to 5, which is also not included like that. Okay, so this is our set C. Okay, so now the question is to find the union. So remember the union, we are just getting everything in set A and combining it with what? Set C. Okay, so we see that the lowest number in set C is 1. Okay, and then the highest number in set A is what? 8. So the union will be all the members between 1 and 8. Okay, so the union will be everything between 1 and 8, where I'm shading here. This will be the union, okay, because we are getting the union there. So we're going to say A union C will just be equals to, okay, so at this one, is the 1 included or not? Okay, there's an open circle here, so the 1 is not included. So we are just going to write, curved bracket. What's happening to my pen? So curved bracket, okay, and then you're going to have 1, comma. Even this 8 at the end point is also not included because there's an open circle here. So we're going to write 8 and then close. Okay, so this here is our set A union what? C. So any questions there?
My question, are we supposed to show like the way you've done, like the shading and showing it on the number line when solving?
Yes, you have to show, because most times the question they say show them on the number line. So you have to show them.
All right, thank you.
Okay.
I
Right.
also have a question.
Yes.
Will it be correct if we were to use square brackets and say square brackets 2 to 7 square brackets?
Yes, it will be correct.
All right, thank you.
No. I've thought of it. No, it won't be correct. Why won't it be correct? Because here only this one is not included. So if I get 1.1, this 1.1 will be included. Okay, or I get 7.9. This 7.9 is in this set. So if we say 2 to 7, no, you should have cut some of the members in that set. So 2 to 7 is not correct. Have you gotten
Understood.
me? Okay, yeah. So if we do that, we would have cut some of the members. Okay, and then let's look at the other one. So the other one is saying what? Let's check. So the other one is saying A intersection B. Okay, so we are getting this guy, we are intersecting it with the B. Okay, so we want to find the common. So A, okay, is given by 3, 8, like this, and then B is given by 2, 7, like this. Okay, so this is what we have here. Okay, so what are we going to do here? Same thing, we're just going to draw a number line like that. Okay, so this number line goes all the way up to minus infinity, and then all the way up to positive infinity. Since they said the universal set is a set of all real numbers. Okay, and then somewhere here you should always put your 0. Okay, and then let's write the numbers we can see here in order here. So we are going to write 2, and then 3 somewhere, and then 7, and then 8. Okay, and then the next thing is to plot them. Okay, so we're going to start with set A. I'm going to plot it in white. So I'm going to shade where the 3 is, and then I'm going to go all the way to what? To 8, like this. So this is our set A. And then let's plot set B in another color. Okay, let's use yellow. So set B says that the 2 is included and the 7 is included. So I'm going to shade this part here. Okay, and then I'm also going to shade just above the 7 here. I'm going to shade it like that. And then I'm going to draw a line like this. Okay, so this is set B. Okay, so now remember, we want to find A intersection B. Okay, so A intersection B means that we are looking for those elements that are common in both A and B. So how are we going to find them? We're just going to go at that region, okay, where the 2 lines for A and B are overlapping. That will be our intersection. So we are going to shade this part here. This is where these 2 lines are overlapping, okay? So that overlap is from 3 to 7, okay? That overlap is from 3 to 7. So it means our intersection, okay, A intersection B will be equals to, so I want to put the brackets here because I want to ask you guys, and then I'm going to write 3 all the way to 7. So what type of bracket should I put here? Should I put the closed ones or the open ones?
The closed ones.
Okay, why should we put the closed one?
Because 3 and 7 are being guarded by shaded circles.
Yes, okay. So they are shaded circles, and both of these numbers are in A and they are also in what? In B. Okay. So no wonder here we're going to put a square bracket like this. Even there we're going to put a square bracket like this. So all the members between 3 and 7, including the 7 and the 3 themselves, are part of this set. Okay, so that one, I think no question is here. Okay, and then the other one is they said we should, that was C, you'd find A complement. Okay, so A complement will have 2 parts. Okay, so this A complement here, we're going to have 2 parts, one on the right and then the other one on the left. So if I write my A here, okay, my A will just be 3 to 8. This is my A. And then when I draw my number line like that, always put 0 somewhere, okay, from minus infinity all the way to positive infinity here. And then I write these numbers, 3 and 8, okay? As usual, we're going to shade above 3 and then put an open circle on 8. So this is our set A, okay? So now they want us to find the set A complement, okay? So how can we find the set A complement? Okay, we are going to go at the specific endpoints for the set A, okay? And then notice what we are going to do. So one of the endpoints is here at 3, okay? So just above 3 here, I'm going to draw an open circle, okay? And then I'm going to go to the left side all the way up to infinity like that. And then here above 8, okay? So here I drew an open circle because the circle below is shaded, okay? So if the circle below is shaded, meaning the 3 is part of this set A. So it means the 3 should not be in the A complement, right? From the Morgan's law, if you remember what we are learning that day. And then here, this 8 is not in set A. So it means it should be in what? A complement. So I'm just going to go above this 8 and then I'm going to shade this guy here. I'm going to shade this guy like this. Then I'm going to go all the way to positive what? Infinity like that. Okay, so it means our A complement will be a union of 2 regions. Okay, the first one will be this one, all the way from minus infinity up to 3. And then we're going to say union from 8 all the way to positive infinity. Okay, so we say it infinity, we always write a curved bracket. And then we are going to say comma 3. And this 3 here is not included in this A complement here, okay? Even this one is A complement. So it means we are going to write a curved bracket. And then we're going to say union. We're going to start where the 8 is. So this 8 is included in this A complement. So this one will be 8, okay, comma, all the way up to positive infinity. Okay, and then curved bracket like that. So this one here is our A what? Complement. So we have the one on the right and the one on the left, and then we are putting them together. That will give us our A complement. Okay, so any questions there, guys? Okay, let's look at the next one then. Okay, so now we are looking at D. What does D have for us? Okay, so on D, we have B minus D. Okay, so B minus D simply means B intersection D complement. Okay, so we are intersecting this B with the D complement. Okay, so let's write the sets that we are going to use here. We are going to use B, okay, which is 2 to 7, both of them included. And then D is equals to, D we had 6, and then all the way to positive infinity like this. Okay, so we can find the D complement just from looking at this set, or if you want, you can still plot it on the number there. It will still show you. Okay, so if 6 to positive infinity, they are in D, then which numbers do you expect to see in your D complement? Okay, it will be from minus infinity, okay, all the way to what? To 6, but this 6 now will be included in the D complement. So we are intersecting this B with the D complement. Okay? For those who are confused, this is the situation that we have on the D. So if this is my 0, and then I have my 6 somewhere, so my D will be from this open circle all the way to positive infinity like that. Okay? And then we want to find the D complement. Since we want to find this set here, we want to find B minus D, which I said is the same as B intersection D complement. Okay, so we are finding this D complement here. So the D complement now will just be, we go above 6, we draw a closed circle here, and then we go all the way to what? Minus infinity. So this will be the D complement here, and then this will be the D. So this is where I've gotten this guy here. Okay, so now we are intersecting this guy with the B. Okay, so let's draw them on the number line. So if this is our number line, positive infinity there, and then minus infinity somewhere there. Of course, always put a 0 somewhere. Okay, and then we have 2, 7, and 6, and then minus infinity. Maybe I should move the minus infinity. Should be, I mean the 0 there. Because the minus infinity, we are going to use it. Let me put the 0 here. Okay, so the 2 will be somewhere there, and then we have the 6, and then we have the what? The 7. So let's plot first this set, the B. Okay, so B is 2 to 7, and the 2 and the 7 are both included. Okay, so we are going to share the circle here on top, even share the circle there, and then we're going to say this here is our set what? B. Okay, and then let's now show the set D complement. Okay, so D complement, remember we found it was minus infinity all the way up to 6. So that's what we're going to shade there. Okay, so minus infinity all the way up to 6. So it means I'm going to the left side like that all the way to minus infinity, and then here I'm ending on positive 6 like that. Okay, so this here is our D complement. Okay, so now what is the intersection between that D complement and the B? Okay, just go where the lines overlap. Okay, so where this, I don't know if this is red. Okay, where this red line is overlapping with the what? The yellow line. Okay, where the red line is on top of the yellow line. Okay, so we know that that region will just be this region here. Okay, so this will be our intersection here. So we are going to say B minus D, which is the same as B intersection D complement, okay, is equals to, so from 2 to 6. And we see that the 2 is included in the yellow set because it's shaded, and here is just within the line. So within the line, meaning it's included. Okay, so we are going to write a square brackets, and then we're going to write 2 comma. And then even this 6 here, it's included because in the red line is shaded, and then in the blue line there, okay, it's within the line, so it's included. So we're going to write 6 and then curved bracket like that. Okay, so this here will be our what? Our answer. So that's our B minus D. Okay, so any questions there, guys? Okay, no questions. Let's look at another one. Okay, let's look at another one. So what do we have there? Okay, so when you look at E here, okay, we have B minus A union C. Okay, so this is the same as B intersection A union C complement. Okay, so that's how we are going to find that one here. So we have B, okay, intersection A union C complement. Okay, so it might be first of use if we plot this guy, okay, and then get its complement, and then that complement now we intersect it with the what? With the B. Okay, so I think we solved this one. What was A union C? Okay, let's check. I think we solved it at the beginning. What was our A union C? Okay, so this was our A union C. Okay, so I'm going to use this. So A union B was from 1 to 8, where the 1 and 8 are both not included. Okay, so I'm going to use that in this our question here. So we're going to say A union C. We know that it's 1 to 8. Okay, right. So let's find the complement of this guy here and then intersect it with the B. So our number line as usual, positive infinity there, then minus infinity here. Okay, put your 0 somewhere. Okay, and then we have 1, and then I can see 8 there. And then what is our set B? Okay, our set B is simply 2 to 7. So it means there's a 2 somewhere and then there's a 7. Okay, so the 2 is included, even the 7 is included like that. That is our set B. And then let's first plot the A union C, okay, and then plot its complement. Okay, so A union C is just starting at 1, going all the way to what? To 8, like that. Okay, so this is our A union C. But we are not interested with the A union C. We want its complement here, okay? So its complement is going to start at the endpoints, okay? So now notice that at this endpoint, this circle is open. So on top, I'm going to draw a closed circle like that. And then it's going to go this side, okay? So this would be our A union C complement, one of them. And then the other one will be starting from 8 all the way to positive infinity. So this one here will also be our A union what? C complement. Okay, so now from this diagram here, is there any point where you can see the set B intersecting with the A union C complement?
No.
Okay, no. Okay, so we can't see any intersection. Okay, those lines are not overlapping anywhere. The yellow lines and the white line there, they're not overlapping anywhere. So it means that intersection there does not have any members. It's an empty set. Okay, it's an empty set. So you are going to say B minus A union C is equals to, okay, an empty set. So an empty set has two symbols. You can write like this, or you can write these curved brackets with nothing inside, okay? Writing an empty set like this, and then you write like this. This is not an empty set. They will mark you wrong, okay? So you either use this or this, okay? So this set here, when we simplify it, it's just an empty set, okay? It's empty. It doesn't have anything because they are not overlapping. These yellow lines and the white lines are not overlapping anywhere. Okay, so any questions there, guys? Okay, let's solve some class question, and then the other ones, I'm sure you can try them, okay? So let's solve F here. So on F, we have A union C, and then minus B intersection D. Okay, so let's solve that one. So if we have A union C, and then we are saying minus B intersection what? D. Okay, so this is what we have here. Okay, so from our previous question, we know that A union C is just simply 1 to what? To 8. So now we have to find this guy here. Okay, remember that this is the same as A union C, and then we are going to say intersection B intersection D, and then complement, because there's a minus here. So we want to find this B intersection D complement. Okay, so the B is given as 2 to 7, and then the D is given as 6 to positive infinity. Okay, so what is their intersection? So if I draw a number line here, a quick one, okay, I'm going to write 2, 6, 7, and then we have infinity somewhere. So here we have 0. So here we have positive infinity. So B will be from 2 all the way to what? To 7. This is B. Okay, and then D will be from 6. So here all the way to positive infinity. Okay, so we can see that their intersection will just be here. Okay, so their intersection will be from 6, and the 6 won't be included because it's not included there. So 6, and then all the way up to 7, and the 7 is included. So this here is the B intersection D, okay? So B intersection D is simply equals to 6, 7, but the 7 is included, okay? All right. So now our interest here is not the B intersection D itself. We want to find its what? Complement. Okay, so let's plot this now. Let's plot this. Okay, so this is our number line here. Okay, here we have 0, here we have minus infinity, and then on the other hand, we have positive infinity like that. Okay, so we are going to write 1, and then somewhere we have 6, 7, and then 8. Okay, so let's plot the A union C first of all. So A union C is starting from here, okay, all the way up to 8. That is our A union C. Okay, and then from here, let's plot this guy here, the B. Okay, the B intersection D. B intersection D is starting from 6, which is not included, all the way up to 7, which is included. So this is the B intersection what? D. So it means we have to find the complement of this B intersection D, okay? Because remember, we are finding this set. Where is it? We are finding this set here, okay? So the B intersection D complement will start from here. I'll draw an open circle all the way up to infinity. Then it also starts from here. I'll draw a closed circle here, and then all the way up to what? To infinity like that. So this is the B intersection D complement. Even this one here is the B intersection what? D complement. Okay, so we see now where is our intersection with the A union C. So our intersection will just be from here, okay, and then we say union, and then we start again from there all the way up to there. That would be our intersection, okay. So we are going to say our answer is just equals to, this one here is not included in the intersection, comma, all the way up to 6, okay. This 6 is included because here it's closed and here it's within the white line. So we're going to write 6 and then union, okay. Here, this 7 is not included there, okay. So we are going to write an open bracket, 7, comma, and then here, the 8 is not. I was getting the answer from this. I was saying this 7 here is not included because we have an open circle here. Remember, we are considering this white line with the yellow line, okay? And then even the 8 here is not included, okay? So this here will be our answer, okay? So this one here will be our final answer. This will be our A union C, and then we had minus B intersection what? D. So this is the answer here. Okay, this is the answer here. So any questions there on how we are ending up with these things, guys? Any questions there? Okay, no questions. All right. Okay, so I'm very sure you can do this, okay, because this starts the same as A intersection B, and then we have a complement. You can also find this, find this, find this, find this, okay? So I'll send some tasks in the group. Make sure you try them out, and then later on, I'm going to send the correct answers, okay? So you can actually mark yourselves. But make sure that you try out the questions, okay? Because if you don't practice math, then you won't know. Okay, so start practicing these same little things that we are doing here. They are the foundation to whatever you're going to do in the set theory. Okay, so if you won't be able to solve these, then you have a challenge in the future. Okay, but if you start practicing now, then it will be very good for you. Okay, because you would have known the foundations, then you'll be able to continue like that. Okay, so unless there are any questions from you guys, otherwise I'll end here for today. Okay, no questions. So I'll send the task shortly that you guys should try. Okay, and then I'll send the answers later on once you have tried. If you won't try them, I won't send the answers. Okay, so we'll continue tomorrow. Tomorrow we are doing I think chemistry. Is it chemistry or physics? I don't know. You should check the timetable. I think it's chemistry. Yeah, chemistry, because yesterday we did physics. Okay, so have a blessed night, guys.
Thank you. Good night.
Good night.